Hello, grade 7. Today's lesson is about waves. Now, previously we've taken many properties of matter, like, for example, what is a solid, what is a liquid, and what's a gas, and how do they change from one state into another. And we also took pressure, which is a property of matter colliding with another matter. Now, we're going to move on to a different approach in dealing with the universe, waves. Waves are a change in the shape of energy to be passed from one place into another. Now, the wave carries energy in different ways or in different shapes. But basically, all waves are divided into two kinds, either transverse or longitudinal waves. So, what is a wave? Basically, it is an energy carrier. We can imagine what it is, but we cannot really touch it. However, we can measure many things about it. Now, how is a wave pictured? Well, basically, it's a change from a straight line. Any change from a straight line carries energy is called a wave. Now, the change in physics is called a disturbance. So, what is a wave? It is a disturbance that carries energy and has a certain shape and also certain properties to carry that particular type of energy. Now, these are the two types of waves. We have a transverse wave, which goes up and down, and a longitudinal wave, which goes in and out, in and out. Both of them are waves. However, both of them carry different type of energy. Let's talk about the first one, longitudinal wave. It moves parallel to the direction of the wave it travels. So if the wave is traveling this way, the vibration change in the same level. That's basically what we mean by parallel. Okay, now example of waves. Well, most importantly, sound waves, because this is the way sound energy is carried, ultrasound waves, and seismic P waves. This is measured for earthquakes or when an object shakes. So, not really very familiar to you. However, sound waves, I'm sure grade 7 you are very familiar with. Now, how does this wave look like? Well, it looks like little things coming together, then moving away. Now, the coming together is called compression. The going away is called refraction. Refraction. Now, what is compression? It's where things come together, so they have high pressure. Refraction, when things move away, so they have low pressure, sort of like gas particles. So, how do we represent them? Well, we represent them by an area of high interactions or compression or low interaction or refraction. So this is how sound waves actually move. At one point, they are compressing air, and at another point, they are releasing air particles. So what does that mean? The energy moves constantly to the right as you move ahead, while media moves left and right, which means the air particles actually shake around, sometimes this way to compress, and sometimes this way to be released from each other or in the state of refraction. So if you talk, it, and we try to look at how air behaves, well, it behaves sort of like in this diagram. At one point, air particles are coming nearer to each other, generally speaking, and this is compression. And at another point, they are moving away from each other. So this is basically how sound energy is carried through a medium. Now, one point has to be added that longitudinal waves work with a medium. So you have to have particles or something carrying energy in order to have compression and refraction. So you can't have them done in an area where there's no matter or in void or when there is no particles. Unlike the other type, which can actually move if there is no particles. So the thing about longitudinal waves is you must have particles for them to work. Now, if they don't work or there's no particles, they cannot work. That's why you cannot have sound when there is no air or in vacuum. Now, the other type is transverse waves, which the ones that go up and down. One example is the ripple of the surface of the water or the vibration in a guitar. Now, a transverse waves has many places or many properties which we need to know. Easier said than done is showing you this is a transverse wave. Now, the properties include rest position, displacement, peak, trough, amplitude, wavelength, and time period and frequency. Now, let me show it to you in the graph because it's easier seen than explained, or you can refer to the explanation later. Now, look, this is the rest position in here. Now, the peak is the top part of the wave. The amplitude is how high is the peak is. The trough is the lowest point. Now, the wavelength is the distance between two peaks or two troughs. So that's basically it. So this is basically the properties of the waves. Now later on, we'll go into how do we calculate the speed of a wave, and that will be explained in the next video. For now, make sure you know the properties, make sure you know the definitions, and if you have any questions, don't hesitate to call me. See you.